All right, so in this lesson, we're going to look at something called percent error. So given two different situations, an estimated situation and an actual situation, you're going to find out what the error was in terms of a percent. So let's go ahead and look at the formula. So this formula looks a lot like the formula for percent change. So in this formula, we have, again, these absolute value bars. And remember that absolute value is the distance away from 0. So we're going to start off with our approximate value minus our exact value divided by the exact value times 100. And remember that this times 100 right here is how you make this number a percent. So you want to make sure that you add a percent sign on to the end of this. Okay? All right, let's take a look here. So we're going to do our approximate value minus our exact value. So we have 40 minus 24, and that's all going to go over the exact value, which is 24 times 100. Now, you're not determining necessarily if this is an increase or a decrease, though you know how to be able to tell that now that we've done percent change as well. So we have 40 minus 24, which is going to be the absolute value of 16, which is just 16. And then we have 16 over 24 times 100. Now, when you do 16 divided by 24, that's going to give you a really long decimal, and it's going to look something like this right here. And it's really 0.666 repeating. Now, your calculator may put a 7 at the end, but that's just because it's rounding it when it runs out of space. So for percent error, you're a lot of times, and even for percent change sometimes, you're going to get a long decimal. Because when you're comparing things from approximate values to exact values, it's not always going to work out to a perfect whole number. And so our rule of thumb will be to always round to the nearest hundredth place, okay? So you're going to take this still and multiply it times 100 in your calculator, and you're going to get something like this. Okay, and it'll go on and on forever because it is repeating, okay? Now, if I'm going to round that to the nearest hundredth, okay, I'm going to round it to here, and this number is going to tell me what to do. So I'm going to have to move that value up. So 66.67%. And that is my percent error. Now, the bigger your percent, the bigger the error, which means the farther off you were. And again, we're going to practice with some basic numbers here, and then we'll look at some real world examples. Okay? All right, so for our next one, we're going to do our approximate value, which is 60 minus 50 over our exact value, which is 50 times 100. Okay? 60 minus 50, that's going to be the absolute value of 10, which is just 10. And then you have 10 over 50 times 100. So when you do 10 divided by 50, you're going to get 0.2 times 100. So no need to round on this one. And so that's going to give you a percent error of 20%. Now, that one compared to the first one, that's a lot less. So we were closer to our exact value in this particular answer. Okay? All right, go ahead and try these two on your own. All right, go ahead and hit pause if you're not done. So for the first one, we had 97 minus 64, which gave us the absolute value of 33. So we have 33 over 64 times 100. Now, when you did 33 divided by 64, you got this exact decimal here, which is still too long. So you did times 100, round to the nearest hundredth, and you got 51.56%. Now remember, the higher the percentage, the farther off your answer was. Or not your answer, the farther off you were in the given situation. And that'll make more sense in a second when we look at some real life problems. Now, over here, we had our approximate value 100 minus 250. That's going to give us negative 150, the absolute value of that. So 150 over 250 is 0.6. And when you do 0.6 times 100, which makes it a percent, you get 60%. All right, so let's look at some actual situations here. And remember that we're going to use the approximate minus the exact over the exact. And then all that times 100. Okay, so Sam does an experiment to find how long it takes an apple to drop 2 meters. The theoretical value is 0.64, but Sam measures 0.62 seconds. Find the percent error. Okay, so theoretical is another word for like a hypothesis. Okay, so that's going to be our approximate value. So we're going to have 0.64 minus the actual value, which was 0.62, and all of that over the exact value, which is 0.62 times 100. So when you do 0.64 minus 0.62, you're going to get the absolute value of 0.02, which is just simply 0.02. Okay, so we have now 0.02 over 0.62 times 100. So when you do 0.02 divided by 0.04, you are going to get, let's see, 0.03125. We're going to multiply that times 100. And that's going to give you still a number that's a little bit too long, so we want to make sure that we round. 3.125, and we're going to round to the hundredth. This is going to tell us to go up, so we're going to do 3.13%. Now, this 3.13% is a lot smaller than some of the other numbers that we were looking at back here on the U-tries, 51.56, 60%, even the first two that we did, 20% and 66.67%. So what that means is Sam, in this problem, his guess was a lot closer to the actual value, which was 0.62. So he was pretty close. He was only about 3% off. Okay, let's look at another problem here. So Jessie estimates that the weight of her cat to be 10 pounds. The actual weight of her cat is 13.75 pounds. Find the percent error. So we're going to do our approximate value first, and that's her estimate, which is 10, minus the exact value, which is 13.75. All of that over the exact value times 100. So when we subtract these two here, we're going to get the absolute value of negative 3.75, which is simply 3.75. So 3.75 over 13.75 times 100. So when you do 3.75 divided by 13.75, you're going to get a long repeating decimal. And it's going to look something like this, but it's going to keep going on forever and ever and ever because it is repeating. Now, we're going to still multiply it times 100, and that is going to give you, once you round it to the hundredth spot, 27.27%. So in this example, Jesse's guess was a little farther off than Sam's guess in the last example because Sam was 3% off and Jesse is 27% off. So remember, the lower the percentage, the closer that individual was to the correct answer. All right, each week Mr. Livingston goes to Harris Teeter. He estimates that he will spend $120 on groceries. He actually spends $94 due to all the coupons he had. Find the percent error. So his estimate, that's the approximate value, is 120 minus the exact value, which is 94. We're going to put that all over 94 and times 100. 120 minus 94 is the absolute value of 26, which is simply 26. So then we have 26 over 94 times 100. 26 divided by 94, again, is going to give us a really long decimal. It'll look something like this. 95747, and it's going to keep going on and on forever. But we're going to multiply it times 100 and round to the hundredth, and that's going to give us 27.66%. Okay, because this 9 right here moves the 5 up. So out of the 3 real-world examples that we've just looked at, Mr. Livingston was the farthest off on his guess because he's at 27.66%. Actually, Jesse was the farthest off. I'm sorry. Oh, but they're pretty close, 27 point something percent. So they were about the same, but Mr. Livingston was a couple more decimal points off, if you will. Okay. Marcus estimates that 230 people will attend the chorus and dance concert. The actual attendance count was 300 people. Find the percent error. So we're going to do the approximate, which is his estimate, 230 minus 300 over the actual value, which was 300, times 100. 230 minus 300 is going to give you the absolute value of negative 70, which is just 70. So 70 over 300 times 100. So 70 divided by 300, that's also going to give us a long decimal, and it's going to be 2.333333333, basically the 3 repeating. Okay? When you multiply that times 100, and you round to the nearest hundredth, that's going to give you 23.33%. All right, you go ahead and try this one. All right, go ahead and hit pause if you're not done. So here our estimated value with the songs on her iPod was 475. So 475 minus 380 over 380. 475 minus 380 is going to give us 95 once we do the absolute value. 95 divided by 380 is 0.25. And when we make that a percent times 100, it is 25%. Okay, go ahead and look at this one as well. All right, go ahead and hit pause if you're not done. So in this example, it says that Daniel calculates the amount to be $4.50, but the actual price was $4. So $4.50 minus 4 is going to give us the absolute value of 0.5. So we do 0.5 divided by 4, and that gives us 0.125. When we multiply that times 100, though, there's no need to round. It's 12.5%. So Daniel's percent error was pretty low compared to some of the others. All right, we're going to end here for this one, but we are going to do a lot more practice in class.